In the vast expanse of the cosmos, where darkness meets the brilliance of a billion stars, lies a realm of giant celestial behemoths that defy comprehension. Among them, dancing in the tapestry of constellations, stand sentinels of unfathomable size and power, challenging the very limits of our understanding. Picture a universe where the scale of existence stretches beyond the grasp of human imagination. Within this cosmic theater, stars reign supreme, each one a glowing testament to the marvels of creation. From the humble glow of our own sun to the dazzling splendor of distant galaxies, stars weave tales of cosmic grandeur, each one unique in its magnitude and radiance. Stars, those glittering jewels in the night sky, are gigantic balls of gases mainly made up of hydrogen and helium. They shine brightly, illuminating the darkness of space, and emit warmth generated by the intense nuclear reactions boiling within their cores. While we're cozy under the rays of our sun, the stars we see twinkling above us are actually incredibly far away, measured in units called light years. These stars aren't just random specks in the sky. They're the basic building blocks of galaxies, those sprawling collections of stars, gas, and dust that populate the universe. Our own galaxy, the Milky Way, is home to an astonishing estimate of around 300 billion stars. What's truly mind-boggling is that stars come in all shapes and sizes. From tiny dwarfs to massive giants, the universe showcases a stunning variety of these luminous orbs. And while we can't count every star out there, astronomers do their best to estimate their numbers and sizes, providing us with glimpses into the vastness of space. Our sun is pretty big, and although it is called a yellow dwarf star, is still massive enough to fit 1.3 million Earths inside of it. But how does our sun compare to other stars in the universe? When you start to think about it, the scale becomes almost incomprehensible. In fact, our sun is quite insignificant compared to some of the colossal giants our universe has produced, such as the mighty UY Scuti. German astronomers at the Bonn Observatory first catalogued UY Scuti in 1860 at the time, naming it BD-12 5055. UY Scuti lies near the center of the Milky Way, roughly 9,500 light-years away from Earth. Located within the constellation Scutum, UY Scuti is a hypergiant star. Hypergiants, larger than supergiants, are rare stars that shine very brightly. They lose much of their mass through fast-moving stellar winds. During their second observation, astronomers realized it grew brighter and dimmer over a 740-day period, leading to its classification as a variable star. UY Scuti's exact size is difficult to pinpoint due to this pulsation. However, recent estimates in 2019 have made the star a bit smaller due to its change in temperature, dropping its initial radius down to a radius of 1,700 solar radii, or 1,700 times larger than our Sun. If UY Scuti replaced the Sun in the center of the solar system, its photosphere would extend just beyond the orbit of Jupiter, and the nebula of gas ejected from the star would extend far beyond the orbit of Pluto. While our Sun can hold 1.3 million Earths, UY Scuti, on the other hand, can theoretically fit 5 billion of our own suns inside of it. But wait, for there exists a challenger to the throne, a cosmic leviathan whose sheer magnitude dwarfs even the mightiest of stars. Behold, in the depths of the Scutum constellation lies a realm where giants roam and legends are born. Here, amidst the swirling nebulae and star-studded heavens, lies the domain of Stephenson 2-18, a celestial colossus whose very presence commands awe and reverence. Lying significantly further away, Around 19,000 light-years from the Earth, it is within a densely populated star-forming region home to several massive open clusters, each containing their own enormous red giant and supergiant stars. Stephenson 2.18 lies within this area, and it is the brightest star among them. Stephenson 218 is by far the largest star discovered yet, and the first whose photosphere, when replacing the Sun, would be capable of engulfing not just the orbits of Jupiter but the orbit of Saturn as well, which lies almost 10 times further away from the Sun than Earth does. This corresponds to a volume of almost 10 billion times that of our Sun, and it's hard to appreciate just how large that truly is. But what is even more bewildering is the fact that it may get larger still as it ages. Stephenson 2-18 is thought to be a relatively young star, and the older it gets, the hotter it will burn, perhaps swelling further and evolving into a yellow hypergiant before it goes supernova. In any case, it is considerably larger than both UY Scuti and any other stars that were previously considered the largest, and is by far the largest known star in the local group. Of course, the universe is vast, and these stars are just the ones that lie in our immediate cosmic neighborhood. After all, we can't measure the size of stars at the other side of the Milky Way, much less the far reaches of the universe, due to there being too much dust and too much interference with light. As a star, such as Stephenson 2-18, approaches the upper limits of a star's size, we still have no idea how massive or heavy stars can get. We might still be in for some pretty large surprises. Over the years, we have continually found larger and larger stars, and so it's reasonable to assume that something else will come along and kick Stephenson 218 off of the list before long. But make no mistake, it will take something truly remarkable to knock this monster off its pedestal as king of the cosmos.